To our probability unit deals with finding probabilities of compound events. But before we get started working with compound events, we want to refresh our memory on what a simple event is. And a simple event is an event that describes one single outcome. So for example, if you have a standard die, you want to determine the probability of a given event when rolling the die, that's a simple event. A compound event, on the other hand, is an event that's made up of two or more simple events. So if a family consists of a father, mother, and 4 children, determine the probability that all 4 children are girls. That's compound because we have the simple events of the first child, the second child, the third child, and the 4th child, but we then need to combine them to find out what would the probability be that all 4 of them had a particular outcome. Now, when we're talking about compound events, we need to understand the difference between mutually exclusive and inclusive events. When we talked about Venn diagrams, we talked about how mutually exclusive looks like this Venn diagram, which simply means that we have 2 events that cannot both occur in the same trial of an experiment. So for example, that could be rolling a 1 and rolling a 2 on the same roll of the same number cube. And so when we have events like this, the probability for mutually exclusive of A and B occurring is going to be 0 because there is no overlap. So then we say, well, what happens to the probability of A union with B, or A or B? And that's where that addition comes in, where we take the probability of A and the probability of B and we add them together. Inclusive events, on the other hand, are going to be those events that have 1 or more outcomes in common. An example of this would be when you're rolling a number cube. If we want to find the outcomes of the probability of rolling an even number or a prime number, even and prime both have the number 2 in common. So when we look at this, we have the probability of A or B taking the probability of A plus the probability of B, but then we subtract off the probability of A and B. So when we have our Venn diagram, you look at it and we say we want the probability of A plus the probability of B, but then we want to subtract off the overlap so we don't double count it. Which when we were working with Venn diagrams, that was one of the things that you had to think about when you moved stuff in to figure out what went in there, because you can't have, with that overlap, you are going to double count things. So before we get started looking at compound events with mutually exclusive versus inclusive, let's review how we calculate the probability of a simple event. We have here a standard number cube and we're going to roll it once. And if you recall, standard number cube has a sample space of 1, 2, 3, 4, 5, and 6. So there's 6 possible outcomes. And the probability of rolling a 5, there's only one way to roll a 5, which means I have a probability of 1/6. When we talk even numbers, I've got 2, I've got 4, and I've got 6, which is 3 possible outcomes that are working for us out of 6 total outcomes, which then we can simplify that to half the time we should get an even number on a number cube. The last one is probability of 7. Well, there's no 7 on a number cube, which means that that probability is 0. It's impossible to get. So now that we've taken a look at a simple event, we need to find the probability of a compound event. Remember, don't overthink these things. Think of it in terms of multiple simple events. So we have here, having 4 children, determine the following probabilities. We want to find the probability of having 4 girls given a family with 4 children. So I first want to think about the probability of having 1 girl. Well, when you have children, as we all know, you can have a boy or you can have a girl. So therefore, that's a 1 out of 2 chance of having 1 girl. So now, being that that's said, we're going to multiply this out because these are independent events. because what you have the first child does not determine what you will have the second child. So we're going to do that 4 times 1/2 times 1/2 times 1/2 times 1/2. And when we multiply that out, 1 times 1 times 1 times 1 is 1. 2 times 2 is 4, times 2 is 8, times 2 is 16. So there's a 1 in 16 chance that this family would have all 4 of their children be girls. So now that we've taken a look at compound events, let's take a look at mutually exclusive events. Remember, mutually exclusive means that they have nothing in common. So we have a standard deck of cards. They have 4 aces and 4 kings, and you draw a card from the deck. So first we want to find the probability of the card being a king and an ace. Well, if it's a king, it can't be an ace because these are mutually exclusive. As you can see, there's no overlap in here. Therefore, the probability of your card being both a king and an ace is 0. So we want to take a look at the probability of our card being a king or an ace. Being that they're mutually exclusive, we're going to end up adding these probabilities. So let's first find our probability of being a king. Well, as you can see, I've got 4 kings in a standard deck out of 52. So that's a 4 out of 52 chance of it being a king. I can divide both those numbers by 4 to simplify it to 1 out of 13. Because there are 4 suits, 13 cards in a suit. One of those cards in each suit is a king. Likewise, we have 4 aces out of our deck of 52, which, as we all know, simplifies the same to get 1/13. So when we take a look at the probability of getting a king or an ace, we're going to take our 1/13 probability of getting a king plus the 1/13 probability of getting an ace, and that gives me a probability of my card being king or an ace of 2/13. So now that we've seen mutually exclusive, now let's talk inclusive. So we want to find the probability on a number cube of rolling a 4 or an even number. Well, if I make a Venn diagram, I have 4, probability of getting a 4, and I got an even number, which is 2, 4, 6. Well, I see that we have 4 in common, so I'm going to put the 4 here, and I've moved these 4s there. So the probability of rolling a 4 or an even number is going to be equal to the probability of rolling a 4 plus the probability of rolling an even, and then we're going to subtract off the probability of it being 4 and even. Probability of rolling a 4 on a standard number cube is 1 out of, not out of 4, out of 6. Probability of rolling an even, well, that's 3 out of 6. And I like to leave it unsimplified just because we have to add them, which means we have to have common denominators. Probability of 4 and even is 1 out of 6. And so 1/6 plus 3/6 is 4/6, minus 1/6 is 3/6, which equals 1/2. So there's a 1/2 or 50% probability of rolling a 4 or an even number. Finally, we have the probability of selecting a card from a playing deck and having it be a king or a heart. I want you to give this one a shot, and then once you've entered your answer, then you can go ahead and check your work. So we want to find the probability from a playing deck of having it be a king or a heart. So probability of king union with a heart. These are mutually inclusive events because we have kings that are part of the hearts suit. So that means we need to find the probability of rolling or picking a king plus the probability of picking a heart, but then subtract off that probability of it being a king and a heart. Well, we have a standard deck of 52 cards, and out of that deck of 52 cards, as we know from before, 4 of them are kings. And we're going to add to that probability of being a heart. We have 52 cards still in that deck. 13 are in each suit that are, and we have 1 full suit that are hearts. And then subtracting off, out of a deck of 52, we have 1 king that is a heart. So we'll subtract that 1 off. And a lot of times when you're talking about things concrete, it ends up being that overlap. Sometimes it's a little more, but usually it's just 1. 4 50 seconds plus 13 50 seconds is 17 over 52. Minus 1 is 16 over 52. Both of these are divisible by 4. 16 divided by 4 is 4. 52 divided by 4 is 13. So there's a 4 in 13 chance of drawing a card from a standard plain deck and having it be a king or a heart. What I need you to do now is to go ahead and complete these U-Try problems. We got A, B, and C here. And go ahead, enter your answers into Edpuzzle, bring your questions with you to class tomorrow.